Hi, welcome to the sort of the last bit of the sequences work. Okay, which is lucky because it's Friday. Okay, if you put a heading in your book, nth term, okay, which looks a bit scary and weird, but actually you've been doing nth term already this week because it's called nth term because the formulas we use for sequences use the letter n. Okay, that's the only reason it's called nth term. Okay, if you put this in your book as we go along, and you can pause the video anytime you're getting behind. Okay, so the proper name for this topic is nth term because the formulas that we use the letter n. And there's no other reason than that. Okay, here's some formulas like last lesson where I asked you to work out the first 5 terms. So if you pause the video and see if you can remember how to work out the first 5 terms, and then when you're ready, press play. Okay, these first two, these are based on times tables. Okay, it means 3 times n plus 8, and because we're timesing by 3, it's like the 3 times table. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. Okay, so that's the 3n part, 3 times 1, 3 times 2, 3 times 3, and so on. And then when you add 8 onto those answers, it actually finishes the sequence. So if I add 8 to 3, I get 11. If I add 8 on here, I get 14, 17, 20, and 23. Okay, so that would be my finished sequence. So in blue, I've got the 3 times table, which is 3n. And then I added 8 to make the numbers in red, which is my sequence. And if I've done it properly, it should still go up in 3s. Okay, because it's like the 3 times table. And it does. Okay, so 11, 14, 17, 20, 23 would be the first 5 terms of 3n plus 8. For the next one then, we're timesing by 7, so 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and this time I've got to take away 1. So 7 take away 1 is 6, 13, 20, 27, and 34, and if I've done it properly, it should still be going up in 7s because of the 7 times table that I used to start with. Okay, so the gap between the numbers matches the times table in the question. So 3n meant 3 times table, gaps of 3. 7n means 7 times tables, gaps of 7. And then you can add and take away if you want, but the gaps will stay the same. N squared is a little bit different because when you square, you're not doing a times table, you're doing square numbers. So 1 times 1, 1 squared is 1. 2 times 2, 2 squared is 4. 3 squared is 9. 4 squared is 16 and 5 squared is 25. That's not a times table because it's not going up by the same amount every time. If I add 4 on, then I get 5, 8, 13, 20 and 29. Okay, and if you look at the gaps, it goes 3, 5, 7, 9. So it's definitely not a times table because the whole point of times tables is that they go up by the same amount every time. So look out for n squared ones. Not a times table, you have to know your square numbers. 1 times 1, 2 times 2, 3 times 3. Okay, now what I want you to do is to put a side heading, working out the formula, and the posh name for that, if you were doing an exam, would be finding the nth term. Okay, so there's your side heading. I'm going to work backwards in this lesson. I'm going to give you the sequence. You're going to work out the formula. But if you follow some easy steps, it's not too bad. Right, first thing I want you to put in your books, because this confuses people. If a question says to find the nth term of a sequence, that is sort of maths language for work out the formula. They never actually say work out the formula. They say find the nth term, and it means work out the formula. Okay, so it's important you understand the language of these questions. Okay, and that's what we're going to be doing for the rest of this video, is working out the formula. And there's sort of a little step-by-step you can follow there. So if you pause the video, write down my step-by-step, and I'm going to use those 3 sort of bullet point instructions, if you like. A posh name for instructions is an algorithm. Use those instructions to find the nth term, and when you're happy, you can sort of pause the video, take over and do some on your own. Okay. So my first example then, and you'll notice in green there I put linear. Now linear, when you're talking about sequences, means a straight line. If you drew a graph of these, it would be a straight line graph like you did a week or so ago. And it'd be a straight line because the gaps between the numbers are equal. Okay, so these are the easiest type of sequences because they go up by the same number every time. If you look at this first one, the gap size is 3, and in my instructions it says first of all to work out the gap size, and if the gap size is the same every time, it's a linear sequence, and it means that we're using the 3 times table. Okay. And if we're using the 3 times table, I know my formula must have 3n, because if we're using a 3 times table, we must be timesing something by 3. Okay. So the gap size is the n part of your formula. So if I label that with a little arrow, look, I'll say that this is the gap size. If the gap size was 5, it would be 5n. If the gap size was 8, it would be 8n. Okay, so whatever the gap between the numbers, that's the n part of the formula. And it tells you what times table we're using. So we're using the 3 times table. So what I'm going to do now, after I've muted my phone, I'm going to write the 3 times table above the sequence, starting from the beginning. So 3, 6, 9, 12, 15. That's the 3 times table, 3n. The numbers in my sequence go 8, 11, 14, 17, 20. So my numbers are bigger than the 3 times table. And if you can work out how much they're bigger by, that tells you what to put after 3n in the formula. So how do you get from 3 to 8? How do you get from 6 to 11? How do you get from 9 to 14? You do the same thing every time. You add 5. So in your formula, you put add 5 on the end, and that's how you find the nth term. Okay. You look for the times table. Once you know what times table it is, write down the n part of the formula, then put your times table on top of the numbers and do some adding or taking away. Okay, let's do another one. Look for your gap size first. This time the gap size is 7. And that means I can do 2 things. The first thing I'm going to do is write 7n in my formula because the gap size is 7. And the second thing I'm going to do is to write the 7 times table from the beginning on top of the numbers. You always start from 7 because it's the 7 times table. Don't start from anywhere else in the 7 times table. Okay, now look at my sequence in black compared to the 7 times table, which is in red. Is my sequence bigger or smaller? It's smaller. Smaller by how many? How do you get from 7 to 3? You take away 4. How do you get from 14 to 10? You take away 4. From 21 to 17, you take away 4. So in my formula this time, I take away 4. So what we're basically saying is that this sequence is the 7 times table, but every number is 4 smaller because we're taking away 4. Okay, I'm going to show you a few now. If you're feeling confident, have a go at these. Pause the video at any time. Pause the video. You have a go, then I'll go through them and you can check your answers. Okay, this one we've got a gap size of 5. Same every time, so 5n. Put the 5 times table on top because it's 5n, it's going up in 5s. Are my numbers in black bigger or smaller? They are bigger. They're bigger by 2, so you add 2, 5n plus 2. The next one is going up in 8s, so you should have 8n in your formula. and the 8 times table written on top, 8, 16, 24, 32, 40. My numbers in black are smaller. Okay, from 8 to 1 you have to take away 7, and it works for all of them. So 8n take away 7. Moving down a bit. The next one is going up in 2s. So it's the 2 times table, 2n, 2, 4, 6, 8, 10. Make sure you go from the beginning of the 2 times table on this top row. Okay, which some people get confused with, because 10 is in the 2 times table, but it's not the first number in the 2 times table. 2 is the first number. Okay, so my numbers in black are a lot bigger than the 2 times table. They're bigger by 8. So you have to add 8 to the 2 times table if you want to start on 10. Okay, the next one goes up in 6s. So I'll put 6n over here in my formula. I'll put the 6 times table on top so I can compare it. Is my sequence bigger than a 6 times table or smaller? It's bigger. Okay, I'm starting on 9 and the 6 times table starts on 6. What do I need to do to the 6 times table? I need to add on 3. Now these ones with stars at the bottom are trickier, so if you want to have a go, certainly do, and then see if you're right or wrong. You might surprise yourself. This one here is not too bad. Look, it's going up in 10s, so that's the 10 times table, so put 10n in your formula. Write down the 10 times table, which has got to be one of the easiest ones of all, isn't it? Okay, now look at the 10 times table and look at my sequence. The 10 times table starts on 10. My sequence starts on 1. What have I done to the 10 times table? I've taken away 9. And you can check it works for all the other numbers as well. So 10n take away 9. Now these star ones, a bit tricky because they got minuses in, and I know that puts people off straight away. So look at this one. It's going up. It's going up in 3s. I know it starts in the minuses, but it's still going up. It's going up by the same amount every time. So 3n. So the 3 times table, you don't need to change your method, it works. Okay, so there's the 3 times table. My numbers in black are definitely smaller because I'm starting on -5. What have I done to the 3 times table? I've taken away 8. So 3n minus 8. And because we've taken away so many, that's why it's starting in the minuses. And that last one there, that's probably the trickiest one of the lot, because this time, look, you're not expected to get this one right, by the way. It's very good if you did. This time the numbers are going down in 5s. So we would say -5 is the gap, because they're going down. All the others went up. So what set of numbers goes down in 5s? The -5 times table. This is why it's the trickiest one. Okay, the -5 times table does this. It goes -5, -10, -15, -20, -25. It's exactly the same as the normal 5 times table, but minus. Okay, and it goes down in 5 instead of up in 5s. Okay, what have I done to the -5 times table to make it start on 6? I've definitely added, because 6 is bigger than -5, but bigger by how many? It's bigger by 11. So you add 11. Make sure you look at that the right way round. You've got to start on the times table and get to the first number in the sequence. Okay, otherwise you'll get your pluses and minuses back to front. So well done if you managed to get all of those right on your own, especially the last 2. And then just before we finish today's lesson, because this is probably taking you a little while with all the writing, I just want to have a look at square number sequences, and the posh name for anything involving square numbers is a quadratic. So that'll be a new name for you, a new maths word for you. We have quadratic graphs as well, which have x squared in them. So anything with a squared is called quadratic. Okay, now then, what makes this bit of the topic special is that the gaps between the numbers are not the same every time. Okay, we saw right at the beginning of the lesson, if I scroll all the way back up here, 3n went up in 3s, 7n went up in 7s, but n squared went 3, 5, 7, 9. And I said that's different, it doesn't count like a times table. So down here what I'm saying is that if the gaps get bigger every time in your sequence, then it must involve square numbers somehow. Okay, and all I want to do is just show you two examples. Okay, first of all, we'll start with the square numbers themselves. So hopefully you recognise that that's 1 squared, 2 squared, 3 squared, 4 squared and 5 squared. Remember, squared is when you times something by itself. So those are the square numbers, and you'll need to know them to do this bit of the topic. Okay, if you don't know your square numbers, you're going to struggle. And if you look at the gaps between them, just like earlier on, it goes 3, 5, 7, 9. And it always does that for squared, n squared. 3, 5, 7, 9 for the gaps. Okay? So if you have a sequence and the gaps go 3, 5, 7, 9, you know straight away, look, to write down n squared. So if you pause the video and get all of that notes in your book, and then we'll do two together. Okay, so this is quadratic sequences using n squared and square numbers, different to a linear sequence which uses times tables. And then if we have a look at some questions then, just two. If you look at this first one, the gap size goes 3, then 5, then 7, then 9. So it's not a times table, it's the square numbers. So n squared. I don't write a times table on top, I write the square numbers on top. So 1, 4, 9, 16, 25, and the next bit is the same. So what do you do to 1 to get to 5? What do you do to 4 to get to 8? What do you do to 9 to get to 13? You add 4 every time. So n squared plus 4, that's finished. And then the bottom one, from -2 up to 1 is a gap of 3. From 1 to 6 is a gap of 5, gap of 7, gap of 9. So n squared again. So write the square numbers on top, just like last time. The square numbers is sort of like a times table. It's worth learning, but it's not a times table because the gaps are different. Now then, this time I've got to get from 1 down to -2, and from 4 down to 3, and from 9 down to 6. So what do I need to put after n squared? Well, to get from 1 to -2, you take away 3. Take away 3, take away 3. So on the end of your formula, n squared -3. Okay, and if you've worked through all of this video today and you've had a go at the questions, well done. If you manage to get them all right on your own, even more of a well done. And we'll do some, like maybe a Google form quiz next week on all of the sequences stuff. Have a nice weekend.